All right, we're going to get started. Thank you for joining us. I don't know, I feel like the evening talks always have a little bit more of a mellow vibe. So this is GitHub for Geographers. My name is John Gravois.
And I'm Patrick Arlt.
And we came up with the idea for this talk series. I think we've been doing one version or another of it for the last couple years.
Yeah.
We've always got a lot of folks that come into Dev Summit. They're either doing GS analyst work or managerial work or some sort of IT. They work with programmers, or they kind of feel like imposter syndrome is there. I feel like with GitHub in particular, people always feel like they're late to the party, or everybody else knows everything about GitHub and they don't. So the goal here is to show you how it works, demystify it a little bit, and sort of give you some tools to go in and explore on your own. Pat and I actually met on GitHub. It's one of the less popular dating sites online, but I knew Pat for a long time solely via GitHub comments back and forth before I ever met him in real life. So
that's a new side project. I'm gonna go do that.
And it can be really fun as long you have to, either be self-started. It's good to have somebody that you can work with. We're gonna work through a demo here, an extended sort of canned scenario that is pretty realistic to give you a chance, but you really got to sort of get in and try this stuff on your own. You don't really learn anything about Git or GitHub until you get tangled up a little bit. If everything's running really smoothly, you want to hit a snag somewhere, and that's where you're going to really start learning. So we're going to hopefully make that concept a little less scary. We're not going to be showing any code or doing anything with code. A lot of programmers use GitHub. We use it extensively at Esri. We use it for open source projects. We also use it for private projects. Yeah? The microphone's not coming out of there? I think it's just because of my point. Thank you for interrupting me.
Can you hear me? Is this all right?
Am I better?
Or is it just that speaker?
The speaker's not doing anything? Oh, is it just that one?
How about on this side? Is it coming out there? Okay.
There's a blue light over there.
I think we could point it. I'm not sure what we should do about it at this point.
I'm just gonna
do it, Pat. This is how we do it ourselves. All right. So that's why they don't do that.
That's because I'm standing here with my mic.
That was all an elaborate trap. So I'll try to speak up a little bit, but too, luckily, I guess we're recording.
Is that any better?
Last year, I was the one doing that. And we don't even have a handheld, and that's not going to make any difference. All right. So if you're sensitive, we can make a little more room on this side. Otherwise, we'll just roll. Oh, there is a handheld mic. That's not going to help with the speaker issue, but. Bear with me a second. I'm going to get more formal. All right. Is that better? No. Well, hopefully that guy will come around, and we'll just roll with it. Okay, so no code. I think a lot of people think you have to be a strong programmer to use Git and GitHub, and that's not true. There's a lot of people that are using GitHub for collaborating on documentation. People are even doing policy discussions and any sort of issue where you want to have a discussion around documents. So there's lots of creative uses of GitHub that don't have anything to do with code. I have met both at Esri and outside of Esri exceptionally strong programmers who don't know anything about GitHub, and people who know a lot about GitHub that are not really strong programmers. So those two things are, they don't have anything to do with each other. That's okay. To make things easier, we're going to focus on a workflow that doesn't have any code, just to kind of focus on one thing at a time. But if you are a programmer or you're wanting to learn some programming, it's a great opportunity. There's plenty of code on GitHub to check out, but that's just how it's going to work today. So you can't really tell in the slides, but this idea of the talk being about GitHub for developers, we call it Git and GitHub for Geographers last year. GitHub, as the name implies, .com is just a website. So GitHub.com is a place you go. There's people hosting all kinds of projects on GitHub. There's a company behind GitHub. and it's what we call a SaaS product. It's you create an account on GitHub. The way GitHub works is they give away that product for free to people who are willing to share their code or their work with everybody. So anything you see on github.com when you're not signed in, that they're just hosting that, and that's, I would say, out of the goodness of their heart, but that's how the business model works. And they charge folks when they want to keep their work secret or private. So if you sign into GitHub and you say, I want to do some work and I don't want anybody else to see it, then they charge you a couple bucks or a lot of bucks. I don't know. Actually, don't know how much it costs. But the website is just hosting for your files. At a bare minimum, if you look here, we got a bunch of projects on GitHub. I just picked one that we work on a lot. Everything here in this file folder, there's folders and files. Think about this as just the same as on your own computer, a directory of files. And so it's hosting the files for you, and that hopefully makes it a little bit less scary. You can dig into the folders and see what all the files look like. But the thing that makes it special is it's tracking not only the way the files look like. You guys might use Dropbox or one of these other things where it's synchronized and keeps them all up to date all the time. The thing that GitHub does on top of that is keeping track of the history of the files and what they look like before. So you can go back in time, or I guess you can't go forward in time unless you do some work yourself. But that's what makes it different. So there's file hosting and there's change archiving. There's also a lot of communication tools. So GitHub, it's a collaboration platform. So the code is here in the first tab. That's when you can see the files. The issues is another way of saying bugs. If somebody finds a bug or they have a suggestion, they're having an issue working with the project, if they need help, they can log an issue. So you can see these discussions and people are talking back and forth, and there's sort of a social aspect. Pull requests are a place to propose changes. So whether you know somebody already or whether you don't, you can propose a change to another project. And this is a big, I would say, like a revolution or a paradigm shift in open source. Many, many years ago, when an open source project got forked, it was like a bad thing. It meant that the people that worked on it, they couldn't agree and they had to take two separate directions, and that was a bad word. GitHub made that a good word and said, no, we're going to make it really easy for everybody to fork and make copies of projects, and they might end up collaborating later, or they might kind of go their own direction, and either way, it's all right. So here's where you talk about the pull requests. And so whether you're actually making any edits or not, you can be a voyeur or a lurker and look at projects. You can look at the code, you can look at the conversations. Here we see an example. If I click on the code here in this branch and I look at the commits are how we have a history of what the files look like before. And the commit is a snapshot, only what changed. Red lines are lines that went away, and green lines are lines that got added or changed. So this commit only has a little bit of information about it, but if I click view here, I can go back to look at that whole file. I can go back to the code, and I can see all of the files. You can deduce what the rest of the files look like at that point in time, and the commit's just a really tidy, concise way to track the change for the whole thing. So you don't have to have redundant copies of the entire directory structure just because there was one little thing different. All right, Git, on the other hand, or sort of the Git component of GitHub, is an open source thing. It's been around for a long time. It was around before GitHub.com. And this is like a real hardcore nerd programming command line tool to do that, all that version control. GitHub didn't invent all that. They're just building a layer on top of the open source bit. So there's other stuff out there like Bitbucket or GitLab or some of these other hosting providers. You could also just run your own server and do all this yourself. And Git's the sort of foundation of how that works. So Git's the command line tool, and GitHub is the product that you can use for free as long as you're willing to share with everybody. So far, so good. For the geographers out there, if the concept of sort of distributed version control is weird, it's the same as versioning in SDE. And when you have replicas and those replicas are synced, it's the same concept. And what makes Git different from other version control out there, it's not the only game in town. There's Mercurial, SVN, there's other version control that's been out. The thing that makes Git unique is this idea, distributing it and saying, there's no one source of truth. There's just Pat's copy and my copy, and no one is more important or less important than the other. That was kind of a difference in a paradigm shift, and something that I think is kind of cool. All right, so now we're going to switch gears. We want to give you a little bit of a sort of conceptual backdrop, and now we're going to kind of start to dig in and go through a workflow.
Okay, so let's assume for a second I found a project on GitHub that I wanted to collaborate on. And the first thing that I would do is I would fork John's project. So if I found this little sandbox that John had and I wanted to contribute to it, I can fork it a little larger. And it'll ask me, where should we fork this to? I want to fork this to my account. And it's going to take a couple seconds. And now I've got my own copy of John's original project. And you can see that this put this under my username, and it tells me that I originally forked this from John's version of Sandbox. But it has its own history, it has its own files. It essentially is another node in kind of the distributed graph that represents all the people who have forked this. So we can take a look at the history and things like that. So if I want to take this copy and I actually want to work with it, I've got to clone it to my computer. So I'm going to clone it, and it'll give me a URL that I can use. And this is how you kind of get started, is I need this URL. So I'll copy that. So I'll create my own fork. And then I'm going to run git clone, and I'm going to clone that URL to my computer. And that brings the copy of the project that's on GitHub down onto my computer. So git clone. So I'm going to clone that down, and it'll clone it. And since the project's really small, it clones it really fast. And then I can get into the sandbox. And now I see that I've got all those same, it's a little too large. I can see that I've got all the same files. I've got a license, I've got a README, and I've got friends.geojson. And that's actually the same thing that's sitting in GitHub, plus some extra stuff. So now I've got a copy of this project sitting locally on my computer that I can work with. So now their graph has 3 nodes. There's John's copy on GitHub, there's my copy on GitHub, and then there's my copy that's on my computer. So the next step is, usually when you're working in this kind of workflow, you would create a branch. And that just creates kind of a copy of the code again on my computer. And you can create as many branches as you want. You can freely switch between them. And we use this a lot when we're developing to try out new features. So if we needed to add a feature, we would create a branch and put the changes for that feature in that branch. And we would just make lots and lots of branches. So I work on the developers website. We'll probably have anywhere from 20 or 30 branches going simultaneously as we work on different stuff and different doc updates and redesigns and prototypes and things like that. So in order to make a branch, yeah.
So you say when you fork something, it's not a branch.
It's not a branch. Yep, so the branches are tracked only in my bit of the repo. So I can have as many branches as I want in my copy of this, and they're independent from John's. So we share the actual repo, but we don't necessarily share the branches.
It's kind of like you cloned his repo as a fork, and then you're branching.
So if you're scratching your head at this point, this is a good normal. This idea of like a bunch of kooky nouns and verbs, it's not going to sink in. It's like, this is the kind of thing that it takes like tactile time. So bear with us, and we'll recap and do the same exact thing at the end, and it'll be like, okay, I think I'm getting it. That's where we should be at this point.
So in order to check out a new branch, I'm going to check out a new branch. That's git checkout -b for branch, and I'll name it updates. And you can see my fancy terminal has told me now I'm on the updates branch. And then I can actually start to make changes here. So I'm going to open it up. This is VS Code. And I'm going to add a new feature to John's GeoJSON file. So I'm just going to go make a change. And you can see there's a lot of nice little editor integrations with Git. So VS Code has helpfully highlighted all these lines green for me. That tells me that I've added these lines to this file. So we're going to save that. Go back to my command line. And then the next step is after I've kind of got this down, I need to commit my changes. So I need to tell Git to start keeping track of this file, this change. And that's done with a command called git commit. And it usually you use git commit -am that says add. So add all the files that have changed, and then we associate a message with those files. So when we look at the history, it's not just kind of a random bunch of file changes. We actually have something we can identify, and that's the commit message. So usually you want these to be kind of short, but also rather descriptive. So add pat to friends.geojson, it tells us that one file has changed and that we inserted 13 new lines of code into that file. And if I want to take a look at all the commit, we can see if I run git log, that outputs a log of all the changes that have happened to this project. So you can see that there's a new commit here that has add pat to friends geojson. So those changes right now, though, still only exist on my computer. They only exist on my branch, which is on my computer. They don't exist on GitHub, and John can't see them or interact with them at all. So we need to push those changes to another place. We need to get the changes onto GitHub. So the best way to do this is git push. And git push generally takes 2 additional arguments. We push it to a remote, which is just another Git repo. So in this case, we're going to push to origin, and that's a shortcut for GitHub, basically. Usually origin is your fork of it. So, wasn't it? If I go back here, I can do git remote show. So show me where origin is, and it says your origin is github.com/patrickarlt/sandbox. So it actually is telling me you've got this available, you can push to it. And then I can run git push origin master. And master is the branch that I want to push. Actually, it's going to be git push origin updates. So I want to push the update branch from my repo up to origin, which is on GitHub. So if I go and I run that, it's going to tell me that it sent all that data to GitHub. And if I flip back to GitHub, it tells me that updates was pushed to 1 minute ago, and I can then take a look at that branch on GitHub and see what the changes were. You need to refresh for that. There we go. So now you can see that updates appears on GitHub, and it appears locally for me. So that still isn't in John's repo. I want the change to end up in John's repo, not in my repo, not on my computer. So this is where that pull request mechanism comes in, because I want to propose a change to a repo that I don't own. I don't have any permission to edit the things that John has. I only have permission to edit the things that I have. So the easiest way to do that is on GitHub, you do a pull request. And it's pretty easy if you just pushed up a new branch, because they give you a handy dandy button right here. So we'll propose that, we'll compare and pull request, and this actually sets it up for you. So this says, I want to merge, it's best to read this right to left. I want to merge Patrick Arlt Sandbox updates into John Gravatt master. And you can see I can customize a message to send to John. I can allow him to edit the files if I want to. And then this is the summary of changes that I'm proposing to John from my repo. So John can then take a look at this, and he can decide if he wants to incorporate those changes. So, and then you see we're back on John Gravatt Sandbox, and he has a new request from me, and then you can confirm that this kind of reads the right way. So Patrick Arlt wants to merge one commit into John Gravatt master from Patrick Arlt updates. So that's the repo that it's coming from and the branch. And then John can also review the changes that I'm proposing and make sure they look okay.
All right. I think you're good. So we're showing a little bit more of a difficult workflow right off the bat. This whole premise assumes that Pat and I have never met before. So I said before that you don't have to pay for GitHub when you want to share your work with everybody. But sharing your work doesn't mean you give everybody else access to edit it. So on GitHub, my project in my folder, I'm the only one that's really allowed to make changes. So they make it really easy for Pat to make a copy and make some edits and propose something to me, but he could never make that change without my permission. So that's kind of the safety mechanism that's built into it. The reason we showed this is because it's a totally normal workflow. Pat and I probably do more communicating via pull requests than any other way as a normal part of what we just call code review. You know, to have several people collaborating on every project, it's a good thing to say, hey, I think this is pretty good, what do you think? And you have a discussion and you make some refinements and then you merge it, even if you were allowed to push it all by yourself. Does that make sense? So this is more complicated. If you look at some tutorials for getting started with GitHub, they'll just have you pushing your own work, and that's a good way to get started too. We're showing a little bit more tricky of a workflow just because it's also useful. It's also common. So up until now, Pat's been showing the hard way to do things like the terminal. He's using a local editor. I'm going to do things the easy way because I'm lazy. If I go back to if I had my email open, I would have got a message when Patrick opened the pull request to tell me, hey, there's something to check out in your project. That's because it's mine. But if you want to lurk on other people's projects, you can watch it, and then you'll get notifications when there's activity like that too. So you can watch projects. I watch some projects that I don't contribute to just because I'm curious about them. So that's open to everybody. If I refresh the page now, I've got a pull request. And I can see this guy I've never met, Pat. He wants to be friends with me. He's telling me he wants to be friends by saying, you've got some GeoJSON. And up until now, if I go back to what the repo looks like for me right now, GitHub has some handy tools for visualizing certain file types. Most of them you just see raw text. But in this case, it parses that GeoJSON and says, wow, John doesn't have any friends at all. There's just this one dot. That's it. And I can look at Pat's and say I had a whole bunch of work in here that was like really important to me and I didn't want anybody to mess around with it. When I review this pull request, this gives me a digestible chunk to say, Pat's got some ideas. They're not going to hurt or do anything wrong. The entire change is encapsulated here. So I can actually, this for an open source maintainer, it makes it a lot less scary to collaborate with other people because it's already isolating the new thing. And I go, yeah, this looks pretty good. And if I wasn't sure if like the curly braces were in the right place and everything was okay, I can view this whole file, not just the diff. And I can say in the tree here,
I didn't change the
He didn't change the geometry? Okay, but this will maybe say Pat now? Now it says Pat. So he's basically saying, I don't know what he's saying by this, but I'm okay with it. Yeah, it's good. So I can go back and I can say, if this is good, I can merge this pull request. So look at this commit hash here. This is the encapsulation of the change. If I click merge and confirm, and I go back to my own code, now in this history, I've tacked on his commit and I merged it in. That adds another commit. This is like making the two nodes in the graph kind of come back to a point. Now I can see this is in my history as well in master. So, it's kind of a mind bend to think. We talked about first a fork, first we just talked about a GitHub project or a repo that lives up on GitHub. Then he made a fork. That just made another copy, but it's still just on GitHub. And that's all the files and all the history. Then he cloned it down to his computer, so he got locally all the files and all the history. Then he made a branch, which is just a component of the history. It's not another place on disk. It's just the files looking a different way in the same exact place. He saved his work. He pushed it up. We merged it in, and then we can do all this again. So this is like something that you do over and over and over again, and it gets more comfortable. So I merged the pull request, and then I'm looking at this. I haven't looked at this project in a while. And I'm like, now that I'm looking at it, this is good. But what we need, it needs something else. It needs a little zazz. So this is a README file. This README is kind of a normal convention to say, like, when people come visit your project, let them know what's going on. This is the documentation. .md is a specific file type. It's just something you open in a text editor. In GitHub here, you can see like we've got some bold text, we've got some links, we've got some an unnumbered list. It's organized and it's kind of more readable. if I look at the raw version of this file, this is just a text file, and this is what we call GitHub Markdown. So there's a subset of a few keywords that help the text look a little bit nicer, help you organize your text. And so like the links just get picked up automatically. If I want to have a link to another file in the repo, I can do that. And so it's just brackets for the words that you're going to show and parentheses for what you want to link to. So this is kind of nice. It's a lot easier than hand editing HTML. So like there's a benefit to sort of becoming a little conversant in Markdown. The other thing about Markdown is if you log an issue or you open up a pull request, when you write some text here, we'll say not big, big. You can preview, you can go back and forth. The raw text of issues and pull requests and all the communication on GitHub, that's always, it's gonna be Markdown. You don't have to know any special tricks. You can just write text if you want, but you can preview it. And then here they even have some tools like you can, it helps create the Markdown for you. So you don't have to know how to write it by hand. But Markdown's kind of the language of GitHub. So say I want to have like something really that's in your face and nice here. In my README, I can skip all the stuff that Pat just did, the terminal commands and the edits, and I can just start editing the text right here in GitHub. So I have the master branch checked out. I can click the little pencil icon, and I can add something in new. I think I got it saved here. So I've got a little image that I copied and paste. I want to add Frank Zappa, a picture of Frank Zappa. I cut my hair, but I still get a lot of comparisons made with Frank Zappa. I feel like he's going to make people more excited about this project. This is an improvement. So here, the Markdown syntax for this, it's a link like any other link with a bracket and parentheses. I just put a bang in front of it. That lets people know it's an image, and this becomes like the alt text for somebody, like for accessibility. So I can edit it right here. I can preview it to make sure it looks good. I haven't saved anything yet. Right now I'm in the equivalent phase as Pat in that I'm editing, but I haven't finished. And then down here at the bottom, when I'm happy, I can commit the changes, and I have to do the same thing Pat did. I could say, added Frank Zappa to the README. Self-explanatory. Here, I can commit it straight to the master branch, put it in master, or I can create another branch, and this is just to kind of keep it separate and on the side. And we create branches for work that's maybe going to get incorporated or maybe not. The master branch is like the most important one, the default one that people see. So this is my project. Nobody's going to tell me what to do. I don't need any code review. I don't need a pull request. I'm just going to commit this. This is cool. This looks good, and I'm happy. I merged his pull request. I added the image, and I'm ready to call it a day now. I think that was good progress for me. So the next step is Pat having another bright idea.
So I got another bright idea because I think it also needs an image. But I didn't notice that John did that. So I'm going to actually check out another branch and keep updating things. I don't know what that was.
Neither. I think it's Frank Zappa.
He's angry at me. So I'm going to check out another branch, and I'm going to put some more updates on that branch. And I'm going to commit some more changes back here. Actually, I know what this needs. If you haven't seen PlaceKitten, this is the kitten-themed placeholder image service. So we're going to just grab a random cat, and I'm just going to put it right here. So we'll add that.
I go line 2.
There we go. So we're just going to add that in. I have no idea what that looks like yet. So I'm going to commit that, git commit. I'm going to add all the files that I've changed. I'm going to give it a message. I'm going to add kittens to the README. And I'm going to push this up, and I'm going to push it up to the same place I pushed it up before. I'm going to push it to more updates. So I'm going to push this up, and this pushes it up to my copy of the repo. So John and I have both added something to our respective repositories on the same line. I'm going to go back to mine. So when I compare this, instead of that little checkbox being green like last time, this actually can't automatically merge these two requests together because we've edited the same line. Because we both edited the same line, Git doesn't actually know what to do. It doesn't know whether it should put kittens or Frank Zappa in the final resulting file. So I can still create this though, and GitHub will let me create it. It'll just say, look, you can't actually merge this. There's a conflict in readme.md. And the nice thing about GitHub, this is something that changed over the last year, you can actually resolve those conflicts. You can tell GitHub whether you want Frank Zappa or kittens in the final file. So if I click, and I can do this, or John can do this. So I can do it since I'm wanting to propose the changes. I can hit resolve conflicts, and GitHub will open up a little editor, and it actually shows the changes. So it shows my changes bracketed by those arrows, and it tells me the branch that that's on. So this is more updates. More updates wants to add a cute cat. And below these set of equal signs, master wants to add Frank Zappa. And I've got to choose one of those two things to win. One of them one of those two changes has to happen. And you can also do this manually. So, because I've been doing everything the hard way, I'm going to do it the hard way. But if you go to the repo, GitHub also gives you, I think I have to look at so GitHub usually tells you, but it doesn't. So we edited the same lines. So now I actually need to pull down John's changes into I need to be able to see those locally. So I'm going to run another git command. I'm going to go grab John's copy of this. So I'm going to grab John's repo. Now I'm going to grab John's URL for his project. And I'm going to add it as a remote. So I'm going to add a reference to John's repository on GitHub so I can reference it on my computer. So I'm going to add that. And then I can do git pull John master. So I'm going to pull down the latest stuff, but I'm going to pull the latest stuff down from John's repository because I need his Frank Zappa changes. And when I pull, Git tells me there's been a merge conflict, and there's been a merge conflict in readme.md. And I can inspect that. I think it's Git. And I can then look in my editor, and I can see that it's actually put the same thing in GitHub. And you can see I have a VS Code plugin that actually shows me, here's what the current change that I did versus here's what John did. This is the incoming change from trying to pull down John's content. And it gives me a nice little, should show up right there. But I can resolve this. And when you resolve a merge conflict, you just need to delete all of the markers that get put in there. So if I delete head and I delete all the markers, we can have both cats and Frank Zappa at the same time together in harmony. So if I save that edit, I can then commit those changes. And then it says, okay, now you're good to go. So now I've resolved the merge conflict on my computer, and I can then push it back up to my changes. And then my changes won't have any more conflicts because they'll tell Git, this is how you should also incorporate John's changes as well.
Git push more updates.
Dang it. More updates. And then if I go back to the pull request, I can see that I now have two commits on here. So we added kittens, and then we resolved the merge conflict, and now it says it's okay, and John can merge this. And we can see that I only added these two lines because I told Git this is how the third line that John added should be incorporated. So I technically, my pull request only changes 2 lines of code. It adds it adds a line of white space, and it adds my cats. So now,
We got to see. Yeah.
all right,
it's
all right.
Money shot.
We'll-
We need to see the. We need to see the sample. Well, there's
it's broken. Place kittens down. Oh,
there's no-
non-image oh man, they're actually broken now. I shouldn't use that as an example anymore.
This is a good.
This is good though.
Yeah,
This is good.
We can use this. So I would say, not to go all like war story on you, but when I first started working with GitHub and I thought I was doing okay, hitting this snag of the merge conflict and what you do about it, that was like the first like hair pulling out kind of experience. And things are a little better now. The problem for me at that point was the text editor that's associated with Git when you pose like Vim or something that only some true neckbeard is like, how do I edit this file? And it made things even seem harder than they were. So now this idea that you can resolve merge conflicts right in GitHub, that's good. Good new text editors that help you out and let you choose mine or theirs, like those are good things. It makes it like a little less difficult to get started. But either way, you want to embrace the hiccups along the road. So moving right along, we're going back to the sandbox. I get another notification from this guy, Pat. He wants to add kittens to the README. I mean, I support that in general. When he pulled down and what he was doing was syncing his branch, the two main causes of having a snag like that would be, one, if you try to contribute to a really busy project where there's edits happening all the time all over the place. That can happen. Or if you started a long time ago, you made your fork a long time ago, and then you came back to it a year later and you were like, oh, I want to work with this again, and your work goes stale. Those are the two kind of situations when that usually happens. Because otherwise, in general, it's very rare that two people edit the same line of the same file. So a lot of times you can just keep working and you never hit a snag because you may be out of sync or you didn't do this work, but you edit two different files and everything's great. So GitHub works most of the time. We're showing you when it's not working on purpose because it will happen to you at some point, eventually. So he's got the cute cat. I like that. I like what I'm seeing. If I click view to see, I catch the same thing. He says, it doesn't work. Maybe he didn't see that the first time. So I'm conceptually in favor, but this isn't perfect. And I see a lot of people when they start using GitHub, they're like, oh, it didn't work. I got to close this pull request and start over and open up a new pull request. Like, I don't want to get caught being not perfect. And for me, GitHub became a lot more fun when it dawned on me that this is just a discussion and we can work through all of our issues. We can talk about it, and whether we know each other or not, we can get there. And the pull request should be considered a live thing until it's not anymore. So I can say, hey, Pat, this is great. I love kittens, but the service that you used wasn't good. Can you fix that and make a commit and you do the work? But I also can say, I know of another service that's really good. I can start collaborating back with Pat if we don't know each other and say, I like this. I want to help this land. I want to be like I don't know what you'd say, not an obstructionist. I want to be really proactive and make friends here. So I can propose something back to him. And just the same way that Pat doesn't have edit access to my copy, I don't have edit access to his copy. Oh shoot, GitHub saw that one too. They have a new little checkbox that by default, when you open up a pull request, it gives you that access to, they're trying to make things easier. So maybe we'll use that. Yeah, we could use that. So I'm gonna make a suggestion to him. So how do I do that myself? I'm gonna do things the easy way because I'm lazier than Pat. And instead of the cloning and the forking and all that, I'm just gonna use github.com. So I'm gonna go back to his copy. This is mine. And I got a link here, so I'm going to go to his fork instead. This is the stuff he's already pushed up. This is the more updates branch that he's got an open pull request for right now. And what am I doing? README here. Cute cat. I'm going to start editing. And a lot of times you'll start editing some other person's project somewhere else and you don't know them. And it'll say, you can't commit this directly because who are you? But you can create a new branch and we'll help you open the pull request. They're just like automating most of the steps. So even though I'm allowed to push to his more updates branch, that's only because he's got the pull request open. We'll forget about that part and we'll get a new cat picture. So we got to go somewhere totally different. Place kittens down. This is at the point where all Creative Commons, everything that happens. That guy? No, we don't have that guy. There we go, kitten rescue, to save the day, to rescue us. So I just want just the live. It's not so fast. I think Google's also making it a little harder to do this, to save Copy link address. Right? No, the image address. That's the one we want. No, it keeps redirecting. It's just going to turn into a talk about how to rip off people's little intellectual property. Where are we going? Is there a good snatch here?
Just do Flickr. Just grab a Flickr search. Because then you can.
That's my kitten right there. This one, or which one? This is
You
ridiculous.
should be able to just grab it.
No, they don't want to let you do that either. All right, this is the point where we've just gone on a complete tangent. So I'll skip that. I'm making an edit. We'll just pretend that it was placekittens.com or something else. We'll just have to forgive the finale. And can create a new branch. So you can do this too. You can kind of, for simple things, skip the download and the clone and everything. You'll say, fix the kitten link. Propose a file change. Oh, man. More updates. I think that was just a network glitch that I've never seen before. Create a new branch, fix link. Okay, so now I am looking at Pat's fork up on github.com. I'm looking at the more updates branch. Oh, I didn't mean to do that. I wanted to propose the change.
You did.
No, well, I pushed it straight in there. I was going to give him a chance to review it and also be. Too bad. He's just going to have
The
to.
UI changes every year and it makes it harder.
All right, there would have been a way to do that. But now I can go to add kittens to README, and now you got a couple of Pat commits and one commit of mine. So now we've kind of both pushed up a little bit of change and got something we're both happy with, and now we can merge this. So it could be a discussion where one person delegates to the other person to tweak things a little bit more. That discussion can be really long or short. It could be more curt or more flowery. Different people have different styles, but this idea of the collaboration tools, that's kind of a good thing. Another great thing about GitHub, or another thing that it makes available. So I make the pull request. We skipped that part. I didn't open a pull request for Pat. But that also kind of addresses this idea of the fact that to GitHub, my copy or his copy, no one's more important than the other. There's just different copies and the file permissions that control what people can do. So for all the visual learners out there, I found this a while ago and I thought it was kind of helpful. It's almost big enough to be useful. So putting all the verbs and the nouns together again. Here, this is all github.com on the right-hand side. So there's your repo or somebody else's repo. Those are all just hosted, the fork and the other one. So then the clone is down here on your laptop, your local copy. The commits you make, so there's a staging area. You've made some changes, but you haven't committed. You can add and then commit. You can push back up and create the clone to come down. It's just a matter at this point of, the more you mess with it, the more you'll forget about the fact later that you're using a bunch of crazy nouns that nobody else has ever heard of or don't make sense to anybody else. I feel like I missed something. We've got a bunch of links in here there's lots of great documentation out there and tutorials. There's also, if you go back to John's sandbox here in the issues, we wrote up some homework assignments, like you need some sort of excuse to get started. So all of the stuff we did, we've documented out sort of how you can go through the steps and test drive it yourself. So there's like one for the forks, one for getting started, and one for keeping a fork in sync. We have a couple more minutes. The only other thing I'll show is we showed like training wheels mode on github.com, and we showed like advanced mode, terminal, and all that. The in between, there are several of these. The one that I use the terminal, but the one that kind of seems the best to me in the GUI, there's different ones that people use. There are GUIs that sort of abstract away the need to make the commands. So you're still going to edit the files yourself, but you can have here's a little freeware thing. So here's another program that you're using, not to edit the files, but to keep track of your commits and help you push and pull and do all that. Yeah.
So GitHub Desktop is, where does that fit in?
The reason, so GitHub Desktop is really good if you're just syncing some changes between your computer and your repo. Like if it's your project and you're working on it, or you're collaborating with somebody else and everybody has permission to the same sandbox, GitHub is probably the best GUI out there because it's really simple. Git Kraken and Source Tree and there's a whole bunch of other ones out there that are a little bit more powerful. They introduce this idea. So say like, for example, I open this and I say I had to do all this work without github.com. Right now, I only know about origin. That's my own copy. The same way as he had to add the remote. I can go to this button here and I can add a remote, GitHub repo. It knows that like 6 or 7 people forked this. So I can just add Pat as a remote, and then it fetches. So what's happening here is all this is doing is issuing the Git commands for me. So right now, I have a reference and I know what happened in Patrick's branches too. So the only other kind of thing that I think is worth showing, if I open up, let me do it from here. So here's in the README, see how it says sandbox? I still don't have that Frank Zappa or anything else. If I go back to Git Kraken and try and figure out how to do this, I have master checked out and I'm gonna pull fast forward if possible. It pulled, and now if I go back, now Zappa is here. Oh, did I never merge his other pull requests? Let's do that too. Yeah, because we're not gonna get the kittens. That's gonna be disappointing, but we'll still do it. Confirm the merge. I go back to Git Kraken. The thing that I think it trips people up about Git initially, but there's a good reason why. You don't want things happening without your knowing it. You want to be in control of the way all these branches lay out. So there's a lot of manual steps. The clone, the fork, the text editing, staging for the commit, the push. Like it's a lot of steps and it seems really tedious, but it saves you from having work you did get overwritten without your, when you don't want it to. So just because I merged that pull request doesn't mean that I know about it in my local copy in the clone. You have to pull every time that you want to get that new stuff. So this is that commit history. This is pushing some buttons, and this is easier than the terminal, but there's reasons for the terminal. The reason why we show the terminal is when you get really tangled up and you start Googling things, I guarantee you will find a Stack Overflow article where they show the terminal. Like that's how you untangle yourself from anything. So it's good to not be scared of it. But that said, if you want to use a GUI most of the time, that's fine. And using the GUI here, like I've got master checked out. If I click and check out this, so now I'm checked out that. If I go back to the terminal, say I'm using both, I go to sandbox, I was the master branch. Now I'm on the more updates branch here too. Like the thing that the GUI is doing for you, it happens on the file system. Does that make sense? So you're not working in the GUI. The GUI is just issuing commands for you. That's, I guess, the better way to think about it. And if I have his branch checked out with QCat and Zappa, or I go back and I check out the master branch in origin, the files are going to reflect that. Every time I check out a different branch, these files on disk, like here I have a view of them in Atom, the files unwind, they rewind and fast forward. The state of the files changes based on which branch you have checked out, and it's the same place on disk. So it's like a little bit of magic on top of the file system. That's what the version control is. You can rewind or fast forward to see what it looks like at different states. And at first, it's kind of a lot to get a hold of, but when you're collaborating with people and you need to sort of keep track of the history, it's super powerful and useful. So I highly recommend sort of figuring out a use case that's going to help you get excited about it or stay excited about it and learn through doing. I think that's all we got. We were happy. We appreciate ruthlessly critical feedback and any constructive criticism. We've got tough skins. We're always trying to improve it. But other than that, that's all we got. We hope you enjoyed it. If you got questions or you want to chat more, we got time, right?
Yeah.
Oh yeah, we got about 10 minutes.
We got a couple minutes.
Yeah.
Sorry, so can you explain? I mean, I think you kind of already explained this, but instead of making a fork, why wouldn't he branch off a reference of your repo.
Yeah, so the reason he forks is because if he skipped that step, if he went straight to Geographers sandbox, anybody can clone straight from my copy. But as of the permissions right now, nobody's allowed to push to this except me. So he could clone it, but he could never propose any changes or do any collaborating until he has the fork where he's allowed to edit. So the fork is the place where you get permissions to a project that you maybe don't know anybody or you wouldn't otherwise have access to.
Yeah, so what you're saying is what we tend to do a lot of private repos at Esri, where we don't fork because it's private, it's just internal inside Esri, so everyone just branches off the same repo all the time. And that can be a little bit cleaner because then everyone just there is kind of a single source of truth. Like we have 70 collaborators on the developer site right now. So having to keep track of 70 forks and then each fork has, 100 odd branches, that's something like 7,000 branches, which is insane. It's easier if everyone just uses the same repo, but for public stuff, it gets into kind of a permissions thing where you do want to fork because you want the edit to be coming from a specific person rather than just kind of coming from within the project itself. So you can do both and both are totally acceptable, but generally when you're doing kind of open source contributions, you're going to do the fork pull model.
So it just kind of keeps track of who, when, and
Yeah.
that kind of stuff.
The other thing you can do is, the clone is only if you need all the history and all of the baggage. If you just want the files, you can just download a zip file of the files and you can edit, you can do whatever you want. You don't have to, you can change your mind later too, but the version control may or may not be relevant to you.
But can I upgrade my fork? Like, let's say I pull a
Yeah.
new fork and then I come back a month later, it's probably stale. So
So that's the beauty of working with branches. If you never make any edits right in master and you do your own work, like the branch is the safe place for the work that's not going to hurt anything else. If you did that and then you come back a month later or a year later, your fork will be stale. Your clone will be stale. They don't get changed without you wanting them to be changed. So if you had made the branch the first time, you can check that branch out, then go back and check out master and fetch or pull down and fast forward and get your master locally in sync in a button click or in one command. You also would have to push that to your fork and then everything's in sync. And then you can check out a new branch and say like, I don't want to check out a branch if I'm stale, I want to be up to date. So that's the most common sort of workflow in the world is like, I looked at this a few months ago, I got started, but I got sidetracked. Then I came back. How do I get a clean footing in my fork and on my clone? That's a totally normal workflow.
Yeah, and that's what pull and fetch do. So this is a command that John would run this when he wants to get information from my root. He would run git pull pat master. He wants to pull down the information from my master branch. Or you could do git pull origin and it pulls it from your GitHub if you're behind. And then there's also git fetch. So I want to fetch information about all the branches that someone else has and bring all of those in sync all at once. You'll see git fetch all a lot, like git fetch -- all, which is get all information about all branches from all origins all at once and update everything you possibly can. So that's kind of the sledgehammer version. But it's pretty easy to get in sync because it has the whole file roll-up history. So it just replays everyone's edits and then you're up to date.
Yeah, just assuming it's someone polite to make a pull request, you made a branch off of a fresh fork.
Yeah.
Well, the crazy part though is if your branch is stale and you made your change somewhere, unless enough time has passed or unless they happen to make edits to the same line in the same file, they don't even know whether your branch that you came off of is stale. Like you can be stale and propose a pull request and add a line, and you don't have to be in sync.
Really, it's just inserting those lines that got edited.
Exactly. So you can get away with not knowing what you're doing and being successful. That's a good thing. So my recommendation is, whether you have a lot of different, I work on a lot of different repos, and at first it was overwhelming, but like through tactile experience, it's like, oh, okay, now some new project, it's the same steps over and over again. So whether you do that, find new projects, or you just do a lot of work, get yourself doing it maybe not every day, every couple of days, until you get some muscle memory and push the boundaries of like whatever's comfortable already. I'll try something different. And I used to, like, I worked in tech support, and we would just be like, we're gonna create merge conflicts on purpose to plow through it, because it sucks when you haven't done it. And if you haven't done it in 3 months, and you didn't do it that many times to begin with, it's just almost as bad as the first time. So it's that brute force where you're like, okay, I'm gonna get myself screwed up, 5 or 6 times, whatever. I do the same thing with my bicycle. I give myself a flat tire to like work on fixing the flat tire. Once you get over that hump, you'll never look back, as long as you kind of, stick with it. And that, I recommend doing it, because the talks are good. There's a lot of great doc out there, but doing it is how you're gonna like really drill it in. Yeah.
Two forks, and then you have like a bunch of different pushes to one. Can you decide on the other fork, like, I just want this push, I just want that push from the other fork?
Yeah, usually you're branch by branch synchronizing based on what you want. So you could have, you don't have to keep every branch in sync, but you'd say, okay, it's really important for me to sync these two. There's even clever things like you can cherry pick and say, from this other branch, there's a bunch of work, but I just like that one commit. There's a lot of fancy stuff you can do. And looking at the docs and looking at tutorials that kind of go into that, I used to all the time be like, well, I've never heard of this command. I'm going to, rebasing today, or I'm going to be, doing a bisect or something. Depends on how much.
Yeah, there's like 1,000 commands that we didn't go over, which do various things because you have the whole history of the project.
And everybody uses a different editor, and the way they do it's the best and right. And if you're doing it different, you're an idiot. So don't take all that with a grain of salt. Just have fun with it and realize that every person that acts like a know-it-all, there's another command they don't know, or they just forgot how much they were banging their head on their desk before. Yeah, and just be patient.
And then for like bigger projects, like big open source projects, how do they make sure that someone just like overlooks a malicious code like that?
That's what the idea of the pull request and the digestible diff is the king. And like any open source project worth their salt, if they saw a pull request, they're going to review the code closely. And if somebody says, oh yeah, you should just add this new dependency, they're going to be like, okay, I'm going to review that too. I mean, there are people who don't review closely, but this idea of they're protective of their project and they can look just at your proposal and either it's perfect or it needs work or they're not going to do it. But that, the steps are the same, and that
Like a intermediate fork that they would test the code in and then push it up to their master.
as soon as somebody's got a pull request open, that branch is available to everybody else. So a lot of times I'll look at a pull request, and if looking at it isn't enough to convince me it's good, I'll fetch that branch down and I'll look at it locally or run some tests or play around with it. The branches switching back and forth. They say branches are cheap. Don't ever be hesitant to branch because it doesn't cost you anything. It's a really lightweight way to switch gears.
I'm trying to find the...
Well, you can't leave dangling edits that are not committed and switch branches. If you switch a branch and you haven't committed yet, that will get carried over. But the commits will get wound and unwound. I keep saying that. I don't know if that's a good way to put it.
I can't find the setting. We've been working on a project lately, which is this repo, ArcGIS, RestJS. There's a new security setting that says you can't merge a pull request unless it has one approved code review from one of the core people on the team. So one person from either me or John or someone else in our core group that's maintaining the project has to approve your pull request before it can be merged. And we're the only ones who have the rights to merge it anyway, so it's got to be kind of double checked. Like someone's got to look at the code, someone has to review it, and then someone can hit the merge button. And only certain people have each of those capabilities. So it's actually it's extremely transparent. And there's all sorts of little security options and things like that you can do.
We hook things up so that we run the tests, the tests on the code get run as soon as the pull request opens. So not only are we looking at it, we're saying, okay, well, all the tests are passing. And so those are additional ways to verify that
Yeah, so
you
you can
want to make it easy
see-
on the maintainers
Yeah.
to make sure they're not doing anything. So it's all about teeing up for success so that GitHub wants to make contributing really easy, and they want to make reviewing really easy. Any other questions? Yeah.
This is the easy one. Can you put the final slide up again so we can get them?
Yeah. That one.
I'm
go
presenting.
back.
I flipped
there you
over
go.
at some point. That's a lowercase o.
This one was not as bad as the other ones with the. I mean,
I'm
Bitly
pretty-
has a.
Yeah.
I guess it's not Bitly.
Bitty. I'm
Yeah.
pretty sure.
Merge or commit a branch, that the branch just stays there or it disappears or what happens there?
After you merge it, it's still there, and you have to go back and delete it if you want. You don't have to, but there's a little button in GitHub that says, "Now that this is merged, do you want to keep it or do you want to delete it?" And yeah, it's like usually. I mean, we'd use throwaway branches like that a lot, and that's thinking about the branch for just that purpose is kind of the normal.
And you
first
can
way.
kind of see this is that project. You can kind of see we've got like a couple branches that have already been merged into master that we haven't went through and cleaned up yet. But they stick around because we could go back to them at some point later and we want to, right? Like we have to go back to the issue that we solved, so we go back to that branch and we can add more changes and just reuse it.
I was thinking on the scenario that you click on the drop down and then you start seeing branches, which one is the one you want?
Yeah, they give you little tools to see which ones are behind, which ones are ahead, which if they have any commits, or maybe they have a lot of nifty tools to kind of help you make sense of that. Like those visualization diagrams, everybody's different, but those are all helpful to get your bearings. And the more you do it, the better. Yeah. Cool.
Well,
Oh, it's our pleasure.
Thanks.
And then you guys like,